Hi guys, today we'll be doing on a cyclohexane drawing using the Newman projection. Alright, we call Newman projection, we need to look through carbon-carbon bonds. So let's take a look at this molecule. Right in front here, this is a 3D molecular model of a cyclohexane. You notice this joint here, all in black carbons, 1, 2, 3, 4, 5, 6, right? And these bonds here represents the hydrogen atom. The two balls here represent the substituent. Let's call them the chlorine and bromine, okay? The one in yellow is chlorine, the one in green is bromine. Okay, so first of all, I'm going to show you how to draw a chair conformer. So as you know, Newman projection, you have to see through this carbon-carbon bond. So that means if you look at my shirt, all right, and you look at this molecule I'm holding at, you are exactly looking through a carbon-carbon bond. Over here, do you see? Now let me tilt it for you. Right now, I rotate and you are looking through the carbon-carbon bond. So now what you see in the diagram is only 4 carbons because this is being blocked by the back carbon. So the way to draw a chair conformer Newman projection for cyclohexane, first of all, you need to draw 2 circles. Big and round circles like this, and then one by the side. Okay, next, you draw these 3 lines. Another 3 lines facing the same direction. And now take note, the last line here must join. Right? This part, these 2 atoms represent the front carbon that you see. Alright? So now, this bond here, how do we depict the one that's at the back? So from this point, we draw 2 shorter lines that connect to the back. And of course, you see there are other bonds emerging out from this carbon here. So I'll just continue. For the back carbon, this is the template. Okay, the template. Now, based on what you see now in this model, we're going to translate the picture. Okay, if you look at this model from the top, you notice that these 2 substituents, the chlorine and the bromine, are 1, 2, 3, 4, 1, 4 substituent. And if you look at this, it's up and down, they are trans. So if we consider this is chlorine, right, which is what you see here, at the back carbon, then where should the bromine be placed? It's over here, bromine is attached to the front carbon of the other side. So front carbon, and we know it points down. So this is Br. And how do we know that it is still trans in the picture? Because it's up and down. So for the rest of these bonds, we will just put hydrogen. Okay? So next thing is, where are the axial and equatorial positions in this picture? You see clearly, those that are pointing to the side, these 4, we are showing the equatorial position. So these are equatorial. And those that are vertical, they must be the axial position. So I just put a label AX, which stands for axial position. Right. Small marking here. Now you might be wondering, what about these 2 carbon? There's bound to be some bonds emerging out, right? If you look at the model again, you see. If you look at this model again, the front carbon here at the bottom should have also bonds. See, bonds coming out. One is pointing down, one is pointing to you, directly to you. So the one that points down, that's easy. I can just put it here, down. And in this case, we have a hydrogen, and of course it is axial position because it's pointing down. But what about the equatorial one? For the equatorial, you just need to push it to the side, and since we know it's pointing to you, we use what we call the wedge bond. Right? And put the H. So this is your equatorial hydrogen of this carbon. Now, the back one over here, this carbon is behind, which represent the top. So, as the opposite, the equatorial position will point to me. So you can put the hashed lines hydrogen as the equatorial position, and the one that points up. Do you see this part? The bond here points up. This must be your axial position. So up, H, this is axial. So now you have the template for the Newman projection of cyclohexane with two substituents, a bromine and chlorine in this. I hope you can translate this picture to the drawing here.